question is sum the following series n sin alpha plus n plus 1 over 1 into 2 sin 2 alpha plus n plus 1 n plus 2 over 1 into 2 into 3 sin 3 alpha plus so on up till infinity. Clearly given series is sine series, so we denote it by s. Let s equals to this series. Let the corresponding cosine series is c equals to 1 plus n cos alpha plus n plus 1 over 1 into 2 cos 2 alpha plus so on till infinity. Here we have added 1 because when we apply c plus iota s at last we have to apply some formula like log of 1 plus x e raised to power x or any binomial. So for that purpose we have to add 1, otherwise the series is not complete. So we have added 1. If you forget to add 1 at beginning, then at the end when you will make the series it will not be complete. So at the end you have to add 1. So you will have to remember it. Now next step is to find c plus iota s. When you combine c plus iota s, here sin alpha plus cos alpha plus iota sin alpha is e raised to power iota alpha. Cos 2 alpha plus iota sin 2 alpha is e raised to power iota 2 alpha. Cos 3 alpha plus iota sin 3 alpha is e raised to power iota 3 alpha and so on. Let here if we take e raised to power iota alpha as x, then the series become 1 plus nx plus n into n plus 1 over 2 factorial x square plus n plus 1 n plus 2 over 3 factorial e raised to power x cube plus so on till infinity, which is binomial expansion of 1 minus x raised to power minus n, and here x is e raised to power iota alpha. So we will get as 1 minus e raised to power iota alpha raised to power minus n. Taking it in denominator, we will get as 1 over 1 minus e raised to power iota alpha raised to power n. Now we have to multiply and divide this with 1 minus e raised to power minus iota alpha raised to power n. When we multiply and divide, we will get this. Now e raised to power minus iota alpha is cos alpha minus iota sin alpha, and in denominator when we multiply 1 with 1 we will get 1, then 1 with minus e raised to power minus iota alpha we will get this. When we multiply this with 1 we get this, and when we multiply this with this we get this. Now bases same, powers are added, so it will become e raised to power 0 which is 1, and taking minus sign common from here we will get this. Now the formula of 1 minus cos theta is 2 sin square theta by 2. Formula for sin theta is 2 sin theta by 2 cos theta by 2. Also e raised to power iota theta plus e raised to power minus iota theta over 2 is cos theta. So e raised to power iota theta plus e raised to power minus iota theta become 2 cos theta. So here it become 2 cos theta, and 1 plus 1 become 2, and with negative sign we will get 2 cos alpha. Now taking 2 raised to power n sin raised to power n alpha by 2 common from numerator and 2 raised to power n common from denominator, we will get this. Now 2 raised to power n will get cancelled out and we are left with this. Now formula for 1 minus cos alpha is 2 sin square alpha by 2. Again taking 1 sin alpha by 2 common from here we will get this. Sin raised to power n alpha by 2 get cancelled out and we are left with this. Now we have to apply de Moivre's theorem over here, and for de Moivre's theorem it should be in the form cos theta plus iota sin theta and angle must be same, and for that sin alpha by 2 can be written as cos of pi by 2 minus alpha by 2, and cos alpha by 2 can be written as sin of pi by 2 minus alpha by 2. Now we can apply de Moivre's theorem. This power will get multiplied with angles, we will get this. Now we have to in statement we have sine series, so we have to find the value of sine. So equating imaginary parts on both sides, we will get on left hand side as s and on right hand side we will get sine raised to power n pi minus alpha by 2 over 2 raised to power n sine raised to power n alpha by 2.